Now that we have a better understanding of half equations and how to balance redox equations with oxidation states, we can now look at how we use electropotentials. So what do we mean by electropotentials? Well, let's say we place a piece of magnesium in a solution of water. Um, Over time, what will happen is that magnesium atoms will leave the electrons on the metal and they will go into solution as magnesium ions. This means that there will be a negative charge on the metal surface as those magnesium 2 plus ions deposit their 2 electrons on the metal and pop into solution. And therefore, the positive ions will become attracted back to the negative metal. And this means that over time, an equilibrium will be set up between Mg2 plus aqueous and Mg solid. Now we can compare these different electropotentials um, looking at different metals. So let's have a think about what do we think the most negative charge on the metal would be when we compare magnesium, copper, and zinc. Well, this actually relates back to the reactivity series when you think about this back to your GCSE days. So, which is the most reactive metal, first of all? Well, we know it's actually magnesium. And we can think about this in terms of equilibria. So, for the magnesium equilibrium compared to copper and zinc will be the one furthest to the left, and therefore that will have the highest negative charge. That will be followed by zinc 2 plus, and finally copper 2 plus. So that's our final order, with our most negative being the magnesium and our least negative being copper. So in our next video, we will look to see how we can actually get numerical values for these electropotentials.